Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Kenneth S. Crane. Okay. As usual, we first come to its statement. Okay. Its statement is the heat capacity of solid organ at a temperature of 2.00 Kelvin is 2.00 into 10 to power minus 2 joule per mole Kelvin. What is the Debye temperature of solid organ? The heat capacity of solid organ at a temperature of 2.00 Kelvin is 2.00 into 10 to power minus 2, that is to say 0.02 joule per mole Kelvin. What is the Debye temperature of solid organ? Dear students, as usual we first come to helping tools. Okay. First helping tool defines Debye heat capacity. This tool number 1 has been shown as equation number 11.2, but actually, dear students, this is not equation number 11.2. This snapshot has been chosen from the book Modern Physics by Kenneth S. Crane at the end of the chapter number 11, in which summary of the chapter is usually given at the end of each chapter, and this 11.2 shows that this is the second topic of 11th chapter. Okay, that is to say, here equation 11.2 may be repeated for some other equation, because second topic of chapter number 11 may contain several important equations, and at the end of the chapter those important basic expressions may be summarized under the same number 11.2, because 2 is the topic of chapter. Okay, 11, chapter number 11, topic number 2. Okay, Debye heat capacity C equal to 12 pi raised to the power 4 divided by 5 into capital R, where capital R is gas constant, or more commonly known as universal gas constant, into capital T temperature over Debye temperature TD, where D is written as a subscript of capital D. Okay, and temperature T over Debye temperature have been written under power 3. Okay, so Debye heat capacity C is equal to 12 pi raised to the power 4 divided by 5 into universal gas constant capital R into temperature capital T over Debye temperature TD whole raised to the power 3. In the next tool number 2, Avogadro's number, sorry. In tool number 2, value of universal gas constant R has been described. Okay, tool number 2 says an ideal gas is one for which the pressure P, volume V, capital V, and temperature capital T are related by PV equal to N capital R capital T within bracket ideal gas law. Okay, here n is the number of moles of the gas present, and capital R is constant 8.31 joule per mole Kelvin, called the gas constant. Okay, gas constant or universal gas constant. Now we come to solution. Okay, solution, we know that Debye heat capacity is given by C equal to 12 pi raised to the power 4 over 5 into gas constant or universal gas constant capital R into temperature capital T over Debye temperature TD whole raised to the power 3. Okay, this implies that from here, if we separate Debye temperature cube, then it becomes alternatively equal to 12 pi raised to the power 4 into universal gas constant capital R into temperature capital T cube over 5C. Then we will take cube root of both sides, and hence we will simply reach the value of Debye temperature TD. Okay, so TD Debye temperature becomes equal to simply capital T, because capital T is already in power 3, so its cube root will be cancelled with 1 by 3 will be cancelled with 3. Okay, so simply T will be left. Remaining factor will be 12 pi raised to the power 4 into gas constant capital R over 5C raised to the power 1 by 3, because it is cube root. So in the next step, we have just used the values of these parameters. Okay, so TD becomes equal to, because capital T temperature has been given as 2.00 Kelvin. 12 is a constant number, pi is also constant number. Pi's value is 3.14 up to 2 decimal places. We also know that pi is a very special number. Perhaps in mathematics it is called transcendental number. Okay, anyhow, pi, that is 22 by 7, is a very special and surprising number. The surprising situation is that its decimal representation goes endlessly. It does not obey any particular pattern. It is non-terminating and non-repeating. Okay, it does not adopt any particular pattern. It does not terminate. It goes endlessly. Okay, this situation is very surprising. Mathematicians are working day and night on this number. Okay, now dear students, in place of T 2.0 Kelvin, 12 into 3.14 raised to the power 4 into value of gas constant or universal gas constant has been used as 8.31 joule per mole Kelvin over 5 into, because value of C is given in the statement, that is 2 into 10 raised to the power minus 2, so it will be converted into 0.0200 joule per mole Kelvin. Okay, because if 2 is multiplied with the 10 raised to the power minus 1, then it becomes 0.2, but if 2 is multiplied with 10 raised to the power minus 2, then it becomes 0.02. Okay, so in the next step, nothing, just simplification. Okay, so simplifying the expression, the whole data within cube root becomes finally equal to 96937.812. Okay, then we will take its cube root. Okay, its value from calculator. 1 by 3. Okay, 1 by 3, dear students, actually mean, for example, 2 into 2 into 2 equal to 8. Okay, 2 raised to the power 3 equal to 8, and 8 raised to the power 1 by 3 equal to 2. Okay, so cube root and mm, power 3 are reciprocal of each other. Okay, 2 raised to the power 3 equal to 8, and 8 raised to the power 1 by 3 equal to 2. Okay, so after simplification our result becomes Debye temperature TD becomes equal to 91.87 Kelvin. 91.87 Kelvin. And this is the end of our problem. This is the end of our video. Till next video.